So in this video, we're going to cover a question that has to do with graphing transformations. So it reads that we have a function and we are asked to write a function of g. So we're labeling the second function g, right? Whose graph represents the indicated transformation on the original graph of f. So the function that we're given, the equation we're given is f of x equals 1 over 2x plus 1. And we're only told one transformation, right? All we're having to do is reflecting it in or over the y-axis. So I'm going to get into the technicalities of it here, and then that'll help definitely understand, how this particular transformation works, and then how does that relay in the equation itself to create this new equation. Okay, so the table to the right here on the screen is something that I found online, and it's always been just a helpful reference or resource piece that I always go to. And what I like about it is that it not only tells you pretty much all the different transformation rules that you will come across, you will be dealing with every function out there. It gets into details about what's going on with the points, and that's where I'm going to kind of focus a lot on. So we're going to zoom in here and just look at what we're going over. So the transformation of focus here is reflection in or over the y-axis. Now the question is, what is that going to look like on the graph? Because I think when you connect the display of the graph, that really helps understand, why it is what it is in the equation and how it pans out with the points themselves. So notice first and foremost that the notation is going to be something like this: f of negative x. Now this is just a very generalized notation, but you're going to see how this pans out. You should have already seen in examples, what this looks like in an equation when it talks about reflection over the y-axis. Now to the right in the third column, we see what's changed. All right. What's changed is that the x values are essentially flipping in their signs. Okay. Now for any type of reflection, anytime we talk about reflecting or mirroring or flipping, we often talk about there being a negative sign, and the negative sign means to negate, to say the opposite of something. So that's always what that usually means, and something to keep in mind anytime you're dealing with negatives. Even within numbers, when we use a negative number, we're talking about a number, but in the opposite position of what the positive number would be on the number line. So considering the points of the f of x function, let's just pick random x values, easy numbers, and plug it into the function to see what are the corresponding y values. Always remember f of x is y. The function itself are the output of the y values, or the y values are the output, you can say. So when we plug in the x values, we're going to see what we get. These are going to be the points that you can definitely plot on a graph, on a coordinate plane, and help form the graph of the f of x. So when we plug in 0, we see that 0 times anything is 0. So 0 is going to cancel out that first term, 1/2 x, and all we're left with is 1. So this is our, as you probably already know or guessed it, is our y-intercept, and we can just see that straight from the equation. When we plug in the other two, we're going to get 1/2, so 1/2 times 1, 1/2 plus 1. Let me just spell it out here. We can rewrite 1 as 2 over 2, so that way the bottom numbers of the fractions are exactly the same. We get a common denominator, and we can add the top numbers. So that gives us 3/2 for the second point there. And then when we plug in 2, we get here 1/2 times 2. That would be 2 over 2, which reduces down to 1. Or you can think of it as the 2's cancel out, leaving the 1 on the top. And so we get 1 plus 1, which is 2. So here's 3 random points that we found for f of x. But this is just, showcasing that you can pick numbers and plug it in to see what you get for those points. This is going to be crucial, though, because when we look at how it reflects, the numbers are going to look quite different, right? Some of them are going to have, or rather specifically the x values are going to have negative values. So again, when we look at the notation, in terms of reflection over the y-axis, let me use a darker color here. If it's reflecting over the y-axis, this means that the x values are going to change or flip in their signs. So just a quick drawing of this, okay? If we were to see a point on one side of the coordinate plane, and if I were to flip, let's say this is a 2, if I were to flip the sign on the 2 of the x-axis and it becomes -2, that point is then repositioned and flips across the y-axis. So that's why when we talk about reflections, we have to consider what is the mirror plane. What is the mirror plane that these points or the entire graph is reflecting over or reflecting of itself, like a mirror, right? So the negative sign represents that in terms of the notation, in terms of the equation. So that's really the only thing we have to do here in order to write our function of g equation. We just need to put it on the x, because again, the x values are what's changing or what's flipping in the signs to produce a reflection over the y-axis. Okay, so we're going to write this equation as 1/2 times -x plus 1. Now you probably guessed it too. Well, we still get -1/2 x. That's still, as you could say, on the function. So then it's going to look like a reflection over the x-axis. And that is correct. Graphically speaking, when it comes to the linear function, it's hard to distinguish between the two. That's the funny part about the reflection and some other transformations regarding the linear function. But the key point here is when it's a reflection over the y-axis, x values are affected. It's going to be what I like to call a horizontal effect. Horizontal effect. Okay, so yes, graphically speaking, and we're going to actually see this now in Desmos, graphically speaking, it's going to be hard to distinguish between the two and to say that it's any sort of difference, but there is a difference, and it's in the points in the coordinate point table, right? So here on Desmos, and you can do the same thing, I just plotted out, or rather typed out the function to graph that f function. Okay, so we have 1/2 x plus 1, and I'm just picking a random point, okay, to represent this reflection. So we're going to see how 2, 2 would flip across the y-axis. So now I'm going to plug in 1/2 times -x. So you can already see it's flipped, but we're going to add the plus 1, all right, to put it in pretty much the correct position that it needs to be. And we see that that point where we see the y value is still +2, but now it's at -2 for the x coordinate. Now it's flipped, right? So it's a reflection of itself, and the mirror is the y-axis. Okay. Again, if you wanted to, you can see how if you wrote -1/2, we get the same thing. Okay, so what was a green line is now a black line. Okay, but it's pretty much the same thing because you can multiply 1/2 and -x to quote unquote simplify it, right? But essentially, it's the same thing on the coordinate plane, but it's different, and more properly, it's going to be x is negative because we're being clear that it's a reflection over the y-axis. All right, so hopefully you found this helpful. And definitely let us know if you have any more questions, and we'd be happy to help. Hope you enjoyed.